Chapter 4, Section 5 is about special functions, and specifically in this section we're going to talk about absolute value graphs. In the past we've talked about absolute value and how that represents distance from zero when you're talking about the number line. Now when we're dealing with absolute value graphs, they're always going to be positive because of the absolute value piece, and the graph shape is going to be like the letter V. So on either side of the graph, the points are going to go up in both directions, and it's going to be a V shape. So it's going to come down to a point, which is known as the vertex, and it's going to shoot back up the other direction. In order for us to talk about these special functions, I want to just kind of go over like what makes something, like what makes a graph a function versus not a function. And we have something called the vertical line test that we can use to kind of show when something is a function or when it's not a function. The vertical line test is when if you can draw a line, a straight up and down line, a vertical line through the graph, and it only hits the graph at one point, that would mean that it's going to be a function. So in these two examples down here, this first one when I drew this kind of that dotted line in, it hits the graph like right here at one spot. That's the only place that it intersects that graph at, so that would be a function. Now the one over here on the right hand side intersects 2 times. So this is not considered a function because it crosses through that graph more than once. Now specifically today in this section we're going to be talking about the absolute value function. When you're dealing with an absolute value function or equation, you're going to have either f of x, because that would be function notation, or it'll say y. Remember in the past we talked about how you can interchange those two things. So f of x or y is going to equal the absolute value of x. And anytime that you put something in for x, because it's in those absolute value bars, it's going to make it come out as a positive number. In order to help us graph this, we're going to want to make t-charts or xy charts. So for this one, I just put in numbers -3, -2, -1, 0, 1, 2, and 3 for my y values. Now, or for my x values. You could really put whatever number you wanted in for x. Now, when I put that in there, because we're dealing with absolute value, it's going to make them all become positive. So you can see how all these numbers in the y column, they're all positive values because you're talking about that distance from 0. So the absolute value of -3 is positive 3. -2 would be positive 2. And then notice down here when they were already positive, they stayed positive. So it doesn't switch them to negative. So don't make that mistake. Now the other thing that we'll have to do is once we get our points, we'll have to graph them. So to graph this here, we're going to go -3 up 3, -2 up 2, -1, 1, and then 0, 0. So you can see how these points are kind of going down, but then when I go to graph this next point, we're back over 1, up 1. So you can see now it's going to shift going back up the other direction. Here would be 2, 2, and 3, 3. Now these graphs would continue on beyond those points. This is just showing what I have in my chart. And then I would connect those dots. And it makes that V shape. So all of your absolute value graphs are going to look like this. They're going to have that shape to them. Now this would be known as like the parent graph because this is like the original, most simplest form of this function. In the future, though, you're going to start to see them add, subtract, multiply your absolute value function piece times something. So I want to show you what those examples will look like. So this next one says to graph y equals absolute value of x minus 3. So I still have the absolute value of x, just like we had on that first kind of example I just went over with you guys. But this one now it says minus 3. So I'm going to create another XY table. And I'm going to pick with the same, or stick with the same number. So -3 to +3. And again, you could put in whatever numbers you want for your XY table. And there will be times too that when you go to graph something that maybe the original numbers that you have don't show you enough for you to see both sides of the V. And so you might have to add more points onto your graph, which you can always do. You can always add more points onto your table. Now for these, I'm putting them in this equation. So for the y here, it's going to look like this. Absolute value of that -3 and then -3. So remember that absolute value of -3 is going to become +3, and then -3 would be 0. I'll show you the next one. You're going to do absolute value of -2 and then -3. So absolute value of -2 would be +2, -3 would be -1. We're going to keep doing this, so I'm going to keep putting in those values. So this next one would be the absolute value of -1, which is 1, -3 would give us -2. When I put a 0 in, you're going to have 0 minus 3, which is -3. Now when I put 1 in, it's going to look very similar to that -1. Because the absolute value of 1 is just 1. -3 is going to get us back to -2. When I put a 2 in, I'm going to get -1. And a 3, I'm back to absolute value of 3, which is 3, -3, which is 0. So these points that I'm highlighting, these are like your coordinates that you're going to want to graph. So left 3 and we're at 0. So it's going to be right there on the x-axis. Then we go left 2, down 1 for -2, -1. Left 1, down 2. 0, down 3. And then we see that shift in the numbers again. So I go right 1, down 2. Right 2, down 1. Right 3. And then I connect and I should see the V shape. If for some reason when you're doing these problems, you don't see the V shape, so if you just see like one side of the graph, what that means is that you need to maybe add more points to your table in order to see the other side of the graph. So there will be times that maybe the points that you start with aren't going to show you enough of what you need in order to graph it, and you might need to include more points, which you can always easily just add more points onto your XY table. Let's do one more example here together, and then you'll have some time to practice this. This one, we're taking 3 times the absolute value of x. I'm going to start by using the same numbers that I used on those last 2 examples. For these ones, you're taking 3 times the absolute value of your x value. So this first one would look like 3 times the absolute value of -3, which would be 3 times 3, which is 9. Then we would have 3 times the absolute value of -2, which would be the same thing as 3 times 2, so we get 6. And then again, these are going to be the points that I'm going to want to graph. About the rest of my chart here, 3 times the absolute value of -1 would be 3. 0 would be 0. And then now we're back to the positive side, so 3 times 1 would be 3, and then we have 6, and then we have 9. And then once again, these numbers that I'm highlighting in the blue, these are like your XY coordinates for your points that you're going to want to graph. Now, on some cases, if your numbers start to get too big, you may not be able to fit them on your graph, which if that happens, you don't necessarily need to include them. Let's see if I have room for this first point. I do. Right there would be -3, 9. But if I had something that went over, like this one only goes up to 10, just like yours does in your packet, if I were to have something over 10, I wouldn't be able to graph those points. So maybe skip those really big points if you need to, and just focus on the ones that you can graph. And see if that gives you a good enough idea of where your point should be to create your absolute value graph. But there's my points. And you can see how this one, the points are a lot farther spaced apart from each other. And that's really because you took that absolute value graph times a 3. That's going to do what we call stretch the graph. So it's going to make that graph really tall and skinny. It's going to make it very narrow. Where back up here on this one, because it was subtracting 3, the original parent graph, that first one I showed you guys at the start of the notes, that one started at 0, 0, and it went up as a V shape. This one just pushed it down 3 from that starting point, and that's all because of that -3. So if you're adding or subtracting a number on to your equation, that's going to move your graph up or down. When you have a number sitting in front and you're multiplying it, that's either going to stretch your graph like this one, or there's another option where it would compress your graph, which just means it's going to make it harder for that graph to grow. And so it's going to be a lot shorter and like wider. Now there's some practice problems. There's actually 4 on this next page. There's these 2 and there's these 2 here at the bottom. I want you to pause the video here, give yourself plenty of time to do these practice problems, and then when you're ready to see what your tables and your graphs should have looked like, then you can come back and continue watching this video to see what those should have looked like. Alright, so for this first one, here are my points that I picked. And then here's my numbers. 6, 5, 4, 3, 4, 5, 6. So here's what your first one should have looked like. Okay, and that should make sense because we went up 3 because of that +3, so it just pushed all those points from the parent graph up 3. For this next one, you should have taken 2 times the absolute value of all your numbers. And I should have been safe using the same set of numbers we've been using in this section. So I would have gotten 6, 4, 2, 0, 2, 4, 6. You can see, even just by comparing these two side by side, just kind of how different they are as far as like what's happening to the graph. The one on the left, was just pushed up 3. So it didn't really change the overall look of the graph. It kind of is going up, over 1, up 1, over 1, up 1 on both directions. The second one, though, it's a little bit different shaped because of that 2 being multiplied. It's stretching that function, so it's not acting the same way as the one on the left here. These next 2, especially this next one, because that -4 is on the inside of the absolute value, when it's inside, it's going to make the graph actually move either left or right. So for this one, if you had started by using your original numbers, so -3 to +3, I would have gotten 7, 6, 5, 4, 3, 2, 1. And then if I went to graph this, This is what I would have seen. Okay? And this is that case I was talking about earlier, that I only see it going down right now. I don't see where it pivots and like starts to go back up the other way, so where it starts to make the V. So when that happens, you might need to add on a couple extra points. So like if I added on 4 and 5 to my table, 4 is 0, 5 is 1. So 4 would be right here, and then 5 starts to go back up, so there's the V. And then you could keep going up that direction. So like 6 would be at 2, 7 would be at 3, and so on. And then you can connect those dots. And then you should be able to see the V. For the next one here, it's a little bit more elaborate with what they're doing. They got a lot going on with this one. You're taking 3 times the absolute value of your x values plus 2, and then subtracting 5. So when you have ones like this that have a lot of operations happening to the absolute values, got to be really careful. Take your time on these ones as you're plugging them in to your calculator or you're doing the math here. So I would have started with your XY table. And you can still use the same sets of numbers. So -3, +3. And when I did that, I got -2, -5, -2, 1, 4, 7, and then 10. And then you can graph it. And as I'm kind of going this way, 1, 2, 3, 4, these are just going to continue to go up. So like if you want to include 2 and 7, 3 and 10 here, you can. If you don't like your V's being kind of like lopsided here, it's not a huge deal if you leave it like this and you just kind of connect your dots. So if you say, okay, these are going to go up this way, and these would do the same thing. You can do that if that doesn't bother you. If that does bother you, you can always add more points like -4, but just know that they would match up over here. So like -4 would have to match up with that 1, or the 0 point. So it would be there. And then -5 would have to match up here with this 1, 4. So it'd be up here. So you could always do that if you want to really get an idea of where that other side of the graph goes. You can just kind of reflect those points over, because it should match because of that V shape that these graphs have. And again, that one, if you look at that side by side with some of these other ones here, this one's got a lot going on. It moved it down 5 because of that -5. So you can see this vertex went down 5 here. So -5. It also went left 2, and that's because of that +2 inside there. So that takes care of those numbers. And then that 3, again, it's acting kind of like what was happening up here. It's stretching that graph.